Hey everyone, my name is Darshan Senthil, and the concept I'm going to be discussing here in this math video is called linear equations. Now, a linear equation is pretty simple to understand. It's actually the more simpler thing in algebra. It's one of the more simpler concepts in algebra, and it shouldn't be too hard if you just pay attention to me closely. I'm going to simplify it as much as possible so you have no troubles here. So let me just show you what exactly a linear equation is, and that is, it's an equation that describes the relation between two sets of x and y values in the first power. Now let's just interpret what this means. So it's all the linear equation does is it sort of gives you if you have two sets of numbers, like a table of x and y values, like let's just do that here, like 1, 2 and 2 and 4. All a linear equation does is tells you how these two are related. All it does is it tells you what sort of relation they have, and it does it in the first power, meaning what equation you get for this will not be higher than the first power. You get no x squared or x to the fourth, anything like that. It's just going to be in the first power. That's all this means right here. So let's just let me just show you how you would convert a table into a linear equation. You just find how they are related. Like here, what would you say is the relation between x and y in this case? So the y values are simply all the x values multiplied by 2. So if you've got 1, you multiply by 2, you get 2 as your y value here. Take 2 as x, you multiply by 2, you get y. So for this, your equation is simply y is equal to 2x. That's all you've got there. So now you may ask why this is called a linear equation, and I'll just show you that in a second here. Now we've got this graph here, and now we're just gonna plot our x values in the x-axis and our y values in the y-axis. Okay, so let's get started. So 1 and 2, it's a point right there, and 1 right, so 2 and 4, it's another point over there. So now if we were to draw a line that went through all these points, we just would try and connect the points here, but to connect the dots, like you could keep going on, like we could keep following the pattern at 3 and 6, we could keep adding points, but it would all, if you connected them, you'd get a line. And that is why it's called a linear equation, because it represents a line on a graph. That's the only reason it's called linear. Now whoopsies. Now all linear equations have one thing in common. They can all be put into the following equation, which is y equals mx plus b. Now this is the standard form of a linear equation. If you can put your whatever equation you're given into this form, it's linear. If you can't, then you've got something wrong. It's not a linear equation. So what we're going to do here is I'm just going to explain what each part of this linear equation means, so you've got a good grasp of this. So the y here is just simply your y value, or if you prefer it in scientific terms, then oopsies, scroll too far, then it's your dependent variable. Look, I'm just gonna write deep variable. So yeah, it's basically your y value or your dependent variable. That's what this y here represents. It's very simple, very straightforward. And the x, also same thing. It's your given x value and your independent variable, meaning that what you put in here will determine what comes out over here. The y has no influence on the x, but the x has an influence on the y, and that's basically all this is saying. This is something that you get in science experiments as well, like the dependent variable, the independent variable. It's the same thing here. So if you're good at if you're good at science, then this should make sense to you. Independent and dependent variables. Yep, so that's all the x and y are. Now the m and the b are just simply things that help you describe the relationship between x and y, because remember, a linear equation just simply describes the relationship between the x and the y. So the m and the b are just gonna help you do that. So let's talk about these two. So the m is called your slope. Don't ask me why it's m, because slope clearly does not start with m, and I'm not entirely sure why either. But if you do find out, just please let me know. It's something nice to learn. So this is, you can think of this as your multiplication factor that you would multiply your x value by to get your y value. That's what you would use this m for. You just put something here, and that would determine what you need to multiply your x by to get your y. Wait, I should probably multiplication factor. It's called your slope, and this is also your rate of change, but I'm not going to write that here because I don't have. But actually, let me just squeeze it in here. It's called also your rate of change, and once we get into more in-depth problems on using this, you will see why it's called rate of change. In like real life problems, they use this is often your rate of change. And this last thing here is simply your y-intercept. And this is simply your addition factor. You could add a number, this is what tells you what you need to add to your x value to get a y. So this tells you what to multiply to get your x, and this tells you what to add. So this is your addition factor. That's your addition factor. And it's also your y when x is equal to 0. So on a table, if we had a table like this, let's drop another one, and if you had 0, 1, 2, 3, and your y started at 3 and then went to 4, or yeah, whatever, 3, 4, it kept going on, then your x intercept would be 3, because when x was 0, your y was 3. So this would be your x intercept for whatever equation this table represented. So yep, that's what your x intercept is. Just get rid of that. Yep, so that's this, and now let me show you this. I'm going to put this in a slightly more simplified form so you can get to know it better. So here's the visual representation of that, and this is basically the same thing as the original equation. Let me just write that down up here. That's y equals mx plus b. It's basically the same thing as this, except it's in a little more easier. It's in a way you can understand it a bit easier. So you take an x value, anything over here, you multiply it by your m, add your b, and then you get out a y. So your m and b can be about anything, any number. So let's just say our equation is y equals 5x plus 3, and we're given 1. Okay, let's put 1 in here. So in this case, let me just change my color over here just to make things a little bit easier, and in this case our m would be 5 and our b would be 3. So wait, yeah, so if we put 1 in here, we'd multiply it by 5, okay, and add 3. So this is 1 times 5 plus 3. So what's 1 times 5? That's 5. 5 plus 3 is 8. So we'd get 8 over here as our y variable. And so hence you can prove by this that 1, 8 is a coordinate on your line. So you could do this for infinitely many variables, and you could put 7 here, you could 8 here, and you would get coordinates for your line. That's one way you could do that. So this is just something to help you out, so you could it's an easier way to visualize how the linear equation works. If you're more comfortable working with this form, it's great too, but this I feel is just a nice way to look at it, like one of those functions you might have seen in elementary school, like 3 plus 2 is what? Something like this. That's how I learned stuff in elementary school as well. So this is basically an easy way to look at this. So now let's just check out some problems as to how we'd write equations like this, and also like take a line on a graph and write how we'd like graph equations like this, and how we'd take equations from here and put it in this form. So let's just check that out right now. Alright, so in this problem we must understand that, so in this problem we've just basically got to write an equation for this line that's given to us. Now how would we do that? It doesn't look very simple, but actually it is. It's one of the simplest things that you'll be doing in this chapter. So all you need to understand is what you need to find. So let's just write our linear equation once again. That's y equals mx plus b. That's all we need to know. So the y and the x, you don't need to write anything because you're assuming that the y and the x can be any numbers on the line. You don't need to plug in anything. So we need to find our m and our b. We don't know what those are. So we need to just find those using our equation here. So first thing we need to do is find slope and y-intercept. Y-intercept. I'm not just going to write y-int. Okay, so these are the things we need to do first up. Oopsies. Okay, those are the two things we need to do right up. We need to find our slope and our y-intercept. So how do you find our slope? Now our slope, we just need to just know this one thing to find your slope. Your slope is simply rise over run, which is why it's the slope. It tells you how far this line is sloping. It's what tells you how the line is going to go, whether it's going to go like this, like this, like this, or that's what this tells you. It tells you what way the line is going to go in. So let me just get rid of that. That's what your slope does. So all you simply need to know is that your slope is rise over run. Put in simple terms, it's your change in x, oopsies, change in y over your change in x. One sec, let me just fix that a little bit. Change in y over change in x. That's all this is. So, but for this particular problem, they've been pretty nice and they've just given us what we need to know. So all this basically means is how this rise is how far up or down we go, it's how far up or down we go in our y-axis, and our x is how far right or left we go in our x-axis. So luckily here we've been given both of those. So we've gone 3 up and 4 across. So that's our slope. Our rise is equal to 3 and our run is 4. So our slope is simply 3 over 4. So this is our m. We've finished half the problem already. So far we've just got our slope. So far the equation is y equals 3/4 of x plus b. We still need to find our b, and how are we going to do that? Now to do that, we're just going to simply solve the rest of the equation, and to do so we're just going to substitute any point on the line and find our b. Like, do you remember the representation where I plugged in an x and then I got a y? So we're just going to do the same thing, except we're going to put in an x and a y, and we're going to solve for our b, because we know our slope, and if we know our y and we know our x, this is the only thing that we need to find, and we will be able to do that right now. So let's just plug in our points. They've given us a coordinate also. They've given us everything we need to know, so we've got a coordinate, and we're just going to plug those in right now. So this is 0 is equal to 3/4 of -2, because -2's are, oh wait, sorry, that's my mistake. It's the other way around. Let's rewrite that. So our -2 is y, so -2 is equal to 3/4 times 0 plus b. And when we got a 0 as our x, it's very convenient because these two just are eliminated, and -2 is our b. This is, so we found our m and we found our b. So now all we have to do is plug those back in over here, and we've got our equation. So let's just write our final equation, and that is y equals 3/4 x plus, sorry, that's minus 2. And that is our final answer for this problem. If you were asked to write an equation, if you're asked this on a test or quiz, this is what you would write on your final answer sheet. So that's it for this problem, just a few more to go, so let's continue. In this type of problem, we're just gonna actually graph the equation. When we're given this, we're just gonna make a line out of it on a graph. This is actually a lot simpler than writing the equation, because now that you've just got the code, you just need to sort of just find out what it means and just graph it put it on the graph. It's so easy. In fact, I'll just do 3 of them over here, just to show you, just to make sure you know how it's done. So let's do this one first. Now, where it's given here that our slope here is -1 and our y-intercept is -3. So we know that much. We can take that much from the equation. So our m is equal to -1 and our b is equal to -3. So that's the first thing you should do when you are going to graph an equation. That's find slope and, or rather not find, but interpret your slope and your, I think that's a better word. So yeah, interpret your m and b. So no, not that, but yeah, interpret your m and b. That's the first thing you need to do. And now that we've got that, we just need to know what to plot. Now, if you remember telling me that slope, I remember me telling you that slope is just simply rise over run. So that's what we're gonna do today. So this is how far up we go, this is how far right we go. That's all this is going to involve. So this is quite simply, -1 is -1 over 1, or it's also 1 over -1. I'm just going to show you that it doesn't matter either way we do it. So first thing we need to do is we need to know our starting point. Where do we start from? And that is simply our b, because if you remember, b is y when x is equal to 0. So that just tells us where we're going to start. So if our b is -3, then -3 is where we're going to start. This is the first point that we have. And now we're going to use our slope. So this is -1 over 1, means we're going to go down 1 because it's a negative number, and 1 to the right because 1 is positive. So 1 and 1. That's a point. Now let me just show you this one as well. So that's 1 up and 1 to the left. That's this and this. Notice that's the same thing. So for when you've got a negative number, you can put the negative on any one you want. You can put it down here or up here, whichever one suits you better. And now this is actually all you need to draw the line, but I'm just gonna just do everything and just do a few more and then show you how it works. So let's keep going down. So down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Okay, so that's all I'm gonna do. And now let's just draw a line through these points. We go like this, and we've got ourselves a line. That's how this line would look here. Let's draw the arrowheads. Always make sure you draw the arrowheads and make sure it extends as far as the graph goes, just to signify that the line goes on. It's not just going to stop anywhere. Just do this. Like, some teachers may not be picky, but just be sure you do this so that you know what you're saying. Just make sure you do that. So let's do the next one over here. So again, this is y is x minus y equals x plus x minus 6. So again, we just find our m and our b. So let's just get rid of all this. So just, let that stay. So yeah, that's all that is. So again, let's just put our m is equal to 1 and b is equal to -6. I'm going to draw this line I'm going to do this in a different color. Let's do green. So there we go. So let's just find our starting point is -6, which is our y-intercept. So down 1, 2, 3, 4, 5, 6. This is where we're going to start. And our slope is simply going to be 1 over 1. So up 1, right 1, up 1, right 1. Notice here that you can also do -1 over -1 because it's actually going to be 1 either way, because negative over negative is always positive. So you can do either way. You can do left 1, down 1, or up 1, right 1. It does not matter. It's going to be the same thing. Sometimes when you haven't got space on your graph, you may need to go the other way. But here we have plenty of space, so that doesn't really matter. So we're just going to do a few points both ways. Up 1, right 1, up 1, right 1, up 1, right 1, left 1, down 1, left 1, down 1. And we have enough points, I feel. So let's draw our line. This one again will go all the way over here. So yeah, draw the heads, and we've got our line. We've got our second line. So this is this equation, and that is the red one. So this is red and this is green. I'm just gonna do that so you know which is which. Let's get rid of this line. Okay, let's continue. So now for the third line, it's a little more complex because we've got a 2 this time. But it looks a little more complicating, but it's actually just the same thing. So I'm gonna do this one in blue. Let's get that. Sky blue. I'm gonna do this in sky blue. So let's get going. So again, just find our m is equal to 2 here, and our b is gonna be +6. So let's just go to our starting point. 1, 2, 3, 4, 5, 6, and there we are, our starting point. And our slope this time is, for 2, it's gonna be 2 over 1. Just whenever you're calculating the slope or drawing a line, just convert the slope into a fraction so you can use this rise over run thing over here. It'll help you a lot if you're struggling with this. And just maybe you can put it in this form when you're writing your, don't put this when you're writing the equation, but if you want to, like, for drawing the line, you can put it in this form just to make things look simpler. So let's put some points down. So this is 2 up and 1 across. 2, 1, 1, 2, 1, and I'm not going to go any further this time because you get the general idea. But we could also go down 2 and left 1. So yeah, that's about it. And now let's put a line through these points. And yeah, that's it. We've got our 3 lines up here. And this is what graphing would look like. And like I said, graphing is really easy. You just need to know how to interpret. It's a keyword. Sorry, my handwriting is not very neat. This is the keyword. You need to know how to interpret these equations and put them down here. It's just like taking a code and drawing something out of it. It's something that you'll need to know everywhere. So that's how this problem would work. And just one last word problem before we wrap up this video. So let's go. Right, so this is the last type of problem we're going to see. I'm going to show you in this particular for this particular section. We'll do a few more later on, but this is the only thing. This is the last problem for this video. So what does this say here? A red sea urchin grows its entire life, which can last 200 years. That's just background information. The diagram gives information about the growth in diameter d of one red sea urchin. What is the average growth rate of this urchin over the given period? Now, the key thing here is interpretation skills. Now, they're not asking you for anything big. You just need to know how to interpret this. So, the growth rate, what is the word rate? When you hear this, the first thing you should know is rate of change. And what is rate of change? Which is your slope. They're asking you for the slope over this given period. So these two things are the age and the diameter of the thing, of the sea urchin. So when it was 30, it was 11.9 centimeters, and when it was 110, it was 15.5. What do you make of this? These are actually coordinates. These are your two coordinates. So the age is going to be your x-axis, because the age determines how large it's going to be, and so age is x and this is y, and that's how we're going to do it. So the first coordinate is going to be 30 and 11.9. That's our first coordinate, and our second coordinate is going to be 110 and 15.5. Doesn't this seem a lot simpler to do now? You can just need to apply the basic theorems that we used in the first example problem, and we'll actually get the answer to this. It's not that complicating. Like I just said, it's interpretation skills, not anything else that's too complicating. So we're just gonna I'm gonna continue in a different color. Let's do red again. So now we're just gonna need to put these in the right order. We're just gonna need to put these in our basic formula, which was change in x over change in y. Change in y. The triangle means change, by the way, over change in x. We're gonna need to use this to sort of solve this. So let's go. So 11.9 minus 15.5 over 30 over 110. Now it doesn't matter in what order you put these, as long as you put the right ordered pair together. Like you could as easily have done 15.5 minus 11.9, but you would have to make sure that you did 110 minus 30 as well. You cannot mix these up. You have to put these in the exact. If you just put a line down here, you should get your coordinate. Like this is a coordinate, and this is also a coordinate. You have to make sure that happens. If it's not, then you're doing something wrong. You just need to be careful about that. So let's do this, and let's get out our calculator here. And yep, here it is. So let's calculate this. So 11.9 minus 15.5. That's negative 3.6. So that was one part of our fraction. Come back up here. And 30 minus 110 is negative 80. Now you can just simply make this 3.6 over 80. It's the same thing, because negative over negative is positive. So let's just do this in the calculator itself. Yeah, 3.6 by 80, and that's 0.045. So the answer is 0.045. So this is the slope of this equation, and you may think that you might have to go on and actually find the y-intercept and stuff, but that's not necessary. You just need to find, it's only asking you for the growth rate, not the entire equation. So just make sure you read the problem carefully, and just make, you can save yourself a lot of work. So just 0.4045 is your final answer for this particular problem, and you just need to make sure you wrote this in the right form, which is cm per year. So it grew 0.045 centimeters every year. That's how much this grew. And yep, that's the end of this video. I hope you found it informative. It was slightly long, I know, but hopefully you managed to keep your focus for the entire time. And yep, thanks for watching. I hope this helps you a lot. See ya.